Good morning, good afternoon, and good evening, everyone, depending on where you're joining us from today. My name is Francesco Del Carpio, and I'm the CFO York Operations Coordinator. And I would like to officially open the first session of our VR XR Training and Education, Knowledge and Experience Sharing Speaker Series. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Tekaronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation and the territory, which is subject to the Dish with One Spoon Wampum Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is a hybrid event, locations, I strongly encourage you to learn about the traditional land upon which you are located. For this, I welcome our moderator and speaker and participants from around the world. Welcome to the webinar. Without further ado, it's my great pleasure to introduce our moderator, Dr. Alsbury-Nealy. Dr. Alsbury-Nealy is an expert in disaster and emergency business continuity management. He has been actively involved in research, teaching, and professional activities in these fields since 1993, and he's also the director of SilicoLabs. Thank you very much, Dr. Alsbury, for this.
Thank you very much, Francesco, and thank you everyone for attending today's meeting. I would like to start with a short introduction about this speaker series because this is the first session of the series. At CFOL New York, we have recently created a unit around use of virtual reality, extended reality training. And this is going to be connected to a number of research centers, labs at York University, and also collaborating with some other labs, research, private sector, public sector agencies using XR, VR in their activities and projects, to learn from each other, share experiences and knowledge, and make long-term collaborations in the area, and also with research centers outside Ontario. And that's the purpose. And I'm sure many of you who are in this field already know that there are a lot of course, interest and growth in use of extended reality, virtual reality in this different field, basically. And estimates are showing that this investment in this area is going to increase significantly over the next few years. And it is a good time, I think, for us to start these conversations around how best we can use AR, VR in training and education. Already there are many universities, colleges, institutions have started using VR, but it is at the beginning. In my view, we have a long way to go. And many of us are experimenting this. And we are hoping that this speaker series create an environment for all of us to learn from each other, share our experiences, and also from your new audiences who are joining us. We welcome, if you are interested in presenting in the future, we welcome that as well. So I don't want to make this introduction too long, but going to our first session is great speakers, young researchers, very much connected in what they are doing. We have two PhD candidates and also an undergrad student presenting. Of course, when I say undergrad student, they are already in professional field doing a lot of work, but they are from University of Toronto. I have had the opportunity, and I'm very glad to meet them earlier last year. We started connecting through what we are doing together. And this is an opportunity for them to share the great works, research activities, project that they are doing in different areas with us today. We have three speakers, and I'm going to read their bio first and then go to the presentation quickly. So we have with us Benjamin Alsbury-Nealy and Benjamin is a PhD candidate at the University of Toronto, studying cognitive neuroscience and memory at Rodman Research Institute. His research aims to better understand the cognitive mechanism and that contributes to humans' ability to learn and from memories in real-world space. In this regard, he employs a variety of cutting-edge behavioral research techniques, including virtual reality and extended reality, augmented reality, in combination with mobile EEG and deep reinforcement learning models. So a combination of new technologies is his research work. And also we have Kyla with us, Kyla Alsbury-Nealy. Kyla is also a PhD candidate in rehabilitation sciences at the University of Toronto. Kyla is also a physical therapist with 8 years of clinical experience and is passionate about knowledge translation, which is what we are all about in this speaker series. Thank you for that. And she applies rigorous assessment techniques to diagnose the root causes of the injury and apply treatment techniques based on education, manual therapy, exercises, and modalities, including acupuncture. Her doctoral research focuses on understanding how healthcare providers can connect with community exercise programs that help older adults with balance and mobility. So again, these are quite interesting application areas for XR and VR. This team has nicely come together working on this area. And finally, we also have with us Chirag Chopra. Chirag is an undergrad neuroscience major at U of T. He's graduate. He's okay. Congratulations. Well, this is in 1 month. Yeah.
Oh, yeah, sure.
So congratulations. He worked at the British Columbia Center for Disease Control, managing a team of COVID-19 contact traces, and founded what's called Pandemos, a youth group engaging in COVID-19 knowledge translation initiatives. He also serves as Chief Innovative Officer at the Airlift Emergency Response Operations. He is currently very interested in discovering high-impact research pertaining to the confluence of mental health and neuroscience, developing inclusive and effective project management strategies, and establishing a collaborative and actionable professional network. And I know Chirag is also working on a number of NGO-related initiatives. He will talk about them, and we are really happy to have all of you with us today. And without further ado, I give the floor to you. But before we start, I should mention that we have a Q&A session at the end of this. Please feel free to ask your question and put your question on the Q&A, and we will go to them as soon as the presentation ends. And I believe our session is up to 1 o'clock, but we will be available for a few minutes after for those who want to stay here to do the demo with us, and also for those of you who are online will continue the conversation. And thank you very much. The floor is yours.
Great. Thank you so much, Dr. Askari. And thank you everybody again for taking the time out to be with us here today for this first session of this VR and education and training series. And it's, like Dr. Askari mentioned, such a timely conversation to have. This technology is so new, and we're exploring the space as well as we speak. So we're going to be talking today about two areas of focus, two areas of study that aren't often put in a room together: behavioral research, neuroscience, psychology, and emergency preparedness. And those are two passions of ours. And we're specifically going to be talking about how at SilicoLabs, we're using extended reality technology to better understand human behavior and how we use that in the context of emergency preparedness. So we'll start here with a few introductions. I'll let Benjamin and Kyla quickly say hello.
Hi everyone, I'm Kyla. Ali gave such a thorough bio, so I feel like I don't really need to add much else, except to say that I'm a co-founder at SilicoLabs as well as the Chief Operating Officer. So great to be here.
Yeah, and yeah, thank you, Ali, for that great introduction. I won't add too much to that. My name is Benjamin. Like Alex said, I'm the CEO of SilicoLabs and PhD candidate. So I'm really excited to be here. This emergency response stuff is really, really interesting to me. It's not something that I thought I would get a chance to explore. So it's been a lot of fun so far. So thank you so much for having us here today.
Awesome. Thanks so much, guys. My name's Chirag. I'm the Chief Business Development Officer at SilicoLabs. Again, just graduated, I think, a month ago with my bachelor's in neuroscience through U of T. So share that interest with quite a few people here. And then serve as Chief Innovation Officer at the Airlift Emergency Response Operations. And AERO, as we call it, as the name suggests, is a group of pilots and planes that provide airlift capacity during times of emergencies. And that's really the role that I'll be starting off with to provide some context to our conversation. My journey with emergency response is quite nascent, and it started with the floods in British Columbia in 2021. I still remember the date. It was November the 13th, and I remember it because it was the 13th. It started raining that day, and it didn't stop raining until December 17th. And we had some of the worst flooding that BC has ever seen. A lot of that flooding washed away roads that connected communities. Because of our geography and all the mountains that we have in BC, a lot of the communities in the interior, because the roads were washed away, now found themselves isolated from the rest of the world. And we ended up putting together a group of private pilots and private planes, small aircraft, Pipers, Cessnas, and some helicopters to ferry in supplies to these communities that required them, and also ferry people, animals, livestock out that needed access to healthcare, essential services, and other supplies. And you can see some pictures here from that response. These are some of our volunteers in our planes. Top left, you actually see one of the communities where we delivered some food to the local community shelter, where they've set up an impromptu food bank for people to pick up supplies as they need them. We did that for about 3 months until January of 2022 and decided to turn this into an organization and did a postmortem of our response and decided to look at what were the challenges we faced and how can we overcome them. And we realized one of the biggest challenges we faced was training our volunteers. We had a lot of volunteers. All of our volunteers really during the response were new. They were untrained, unfamiliar with the high-risk environment that is an airport and the tasks that they would be doing in this sort of emergent scenario. So we realized that we needed better ways of training people, getting them accustomed to the tasks that they would be doing in an emergency that they don't necessarily do in everyday life, as well as for them to be able to do these tasks in environments that are applicable to real life. So learning to do them in airports, logistics facilities, etc. We went down that path and we started exploring a few options. We very quickly understood that there are a few very glaring issues or barriers that we would come across. We started off with our typical pen and paper training. We did a tabletop exercise, and we realized those on their own tended to be quite abstract and inadequate. We didn't really get any feedback data from participants of that exercise, and it was very limited to logistics. You know, we could plan out a theoretical flight, and really we couldn't do much more than that. And it wasn't necessarily applicable to real life. We could only throw so many complications at our volunteers in a pen and paper type setting. We then moved on to trying a real world exercise. We did what we called Operation Thunder Run in collaboration with a whole bunch of other aviation organizations from British Columbia all the way down to New Mexico. The simulation was preparing for an earthquake along the Cascadia Fault, and we airlifted or practiced airlifting about 15,000 pounds of supplies from our base, which was Langley in BC, down to Bellingham, close to Seattle in the United States. It was great. Our pilots got to practice our protocols. We did, however, at the end of the day, foot a bill of about $15,000. And that is to say, with a lot of our pilots being volunteers and the spaces being donated to us, our costs were quite limited. But still, we footed quite a bill. It costs, a couple $100 per hour to operate these aircraft and renting out the airport facilities, etc. So we realized that real world exercises would be quite cost prohibitive for us, and they didn't really help us develop any strategies to manage or train emergent volunteers as they would show up in a real life emergency situation. We were also well aware of digital simulations as an option for us. These simulations are quite often used in the aviation space with flight simulators and all. What we did also come across there is, again, the cost prohibitiveness. There's an expertise of the developer that you need to be able to develop effective, immersive, interactive experiences and exercises in these simulations. And then long development lead times, months on end, to develop these exercises for us in a digital space. And then moreover, we would get a hard-coded product at the end of the day that if I wanted to change my sequence of events, fix up the exercise, change my procedures for the next year's exercise, I'd have to go back and go through again the whole process of redeveloping that exercise. So we kind of parked our ambitions there a little bit and decided to work with what we had until I came across Benjamin. Both of us were in the same university at U of T, and we were in the same faculty of arts and science. We got talking about his project, or his company, SilicoLabs, and their mission of democratizing access to extended reality technologies for the purpose of training and assessment. And that got us quite excited, and we put together a bit of a proof of concept along with SilicoLabs. And I'll switch my screen here and lead you guys through a desktop version of what could also be VR. And I'll let Benjamin talk us through some of the key features of this proof of concept.
Yeah, thanks a lot, Chirag. So yeah, this is really interesting. Like Ali said, when he introduced me, I was coming from a very basic kind of neuroscience background. I was really interested in teaching people things and having people learn things in realistic environments, and then testing their memory for those things to see what factors influence that type of learning. And so when Chirag came to me with this proposal of creating a digital simulation for their training, I thought, well, maybe we could do this. I don't know. But it was cool to see that as we started working together, that what I had built for very basic science was a really awesome tool actually for real world simulations and emergency response. It was really exciting to come across that, and it was kind of interesting to apply these basic research techniques to actually training people in real world environments. What you're going to see here is we created a proof of concept. This is actually Chirag is delivering this through a website, so this is something that you could send as a link to somebody anywhere, and you could have them complete this. It's also something where you could set up a computer, when that emergency is happening. So when folks show up to the emergency site, if they're not trained, instead of taking precious human resources to train those folks and show them around and get them all the information, we can actually just present them with this virtual training task. And as you'll see, it teaches them a lot of things. So the first thing that this does is it's going to teach them where all the different areas of the airport are, and what areas of the airport are off limits and stuff. So this first mission is just to become familiar with the emergency response zone, so the area of the airport they're going to be working within. And so there's 4 different zones. We're going to walk through those, and they're just using the AERO keys on their keyboard to move through these environments. And you can see that you can add a mini map too, so they can actually see an overview of the environment too, which we know from my research and from decades of research, that having an allocentric view or a top-down bird's eye view of the environment actually accelerates learning as well. So that's something that you just can't do in the real world as well. So what you'll see is that as Chirag is moving through this, and I think that it might be quite laggy for the Zoom folks, but if it is a little choppy, just know that that's not how it is. It's actually quite smooth in real life. And you'll see that as Chirag moves through the different areas here, when he goes onto the tarmac, this is a restricted area. So we can teach people that this is a restricted area. You're not allowed to go there, but we're just teaching them all the different areas where they're going to be performing their tasks that day. And as you see, as they move through that, we're actually giving them feedback. We're actually able to tell them where they are. And once they've gone to all the areas, we can tell them, oh, you've discovered all the areas. That's great. But not only do we want them to go around the areas, but we want them to really know these areas. So we can incorporate and we can use a mix of 2D and 3D tasks. So now we're asking the participant to actually click on those areas so that we can ensure that they know where those are. Maybe Chirag, if you want to click, you can click on I think one wrong one, just so you can see. So if they click on an incorrect area, it's going to tell them. And actually, we won't do this now, but if they clicked on 2 incorrect areas, it would actually take them back to that navigation task where they would have to go and explore the areas again. And we would have them redo that and tell that they were really familiar. So you can ensure that people are actually learning these things beyond just putting them into the simulation, which is super important. Next thing we wanted to teach them was, who do they need to talk to? Who are the people that are in charge, And so this next mission is actually, it's going to teach them who the managers are by asking them to go and locate those managers and say hello to them. So here again, and with the software, what's really cool is you can take the same environment and create these modular tasks where you can put different types of objects within that environment. So you'll see that now in this task, we've actually placed these avatars at different locations. So we have these avatars. Here's one at the here's Georgina. She's the head of the admin team. So this is the admin section. And then Chirag will go out and talk to one of the other managers. And you can see that we can provide really easy feedback for when they do meet the managers. So you'll see on the left, we actually, that's a question mark over their face. And as they approach that manager and talk to them, it shows up. And again, now we can test to make sure that they, again, know who those managers are. So in this case, we're actually asking, oh, who's in charge of this? Who's in charge of this? So I think, Chirag, you can just go through that. Again, if they were to get too wrong on this, it would take them back to the start of this training task. And then finally, we can actually teach them what they're actually going to be doing, their activity. And as Chirag said, we are demonstrating this on a desktop version. So this was something that they wanted to have so that they could just send this out to folks that don't have a VR headset. But this can actually be easily transformed into a VR or extended reality task. So the software allows you to create one task that can be exported to desktop or to VR. And we'll definitely get into the VR in a bit, but just to give you an idea. And so here you can actually, Chirag can actually go and check the inventory and stuff like that. So over here, he's going to go and see how many units of each thing they have left. And I think that might be a good place. I don't know if we have to go through the whole exercise, but Chirag can actually input all of those, all of those units and then go back and report back. And if those units are wrong, then again, we would repeat that task to ensure that people learn. The next task after that is actually going and collecting those items. So actually going and collecting a certain amount of those objects. In VR, we can actually have those participants pick up those objects and bring them over to the skid, which is going to be loaded onto the plane. So we can actually have them do a virtual simulation of what they're going to be doing. As soon as they exit that training program, which you see takes maybe 10 to 15 minutes for the average person, they can go enter the airport, the real life airport, and they know exactly where they need to go, where they can't go, who they need to talk to, and the tasks that they're going to be doing. All that information really speeds up the response time, and it decreases the amount of human resources it takes to, attend to any volunteers that show up that aren't trained or don't know what they're doing. So.
Thanks so much, Benjamin. What I'll add to that is, this is a proof of concept, right? The tasks that we have built out here were more to prove a few things for us. And the first thing that this proved was, or this showed to us, that we can develop digital twins of our real life response environments and then actually have our volunteers practice within those twins. Of course, with some more development capacity, we can develop these into hyper realistic, real life looking twins, but this proved to us that it's possible. And we know time and time again through established research that if you're performing in the same environment or identical environment that you're training, your response and your performance is going to be increased. There's been studies done on students taking exams in their lecture halls versus in an exam center, and actually doing better in their lecture halls because that's where they've learned the information. So for us, being able to transfer that knowledge into our digital environments was pretty key, and that we knew was possible. The other thing was being able to simulate some of the tasks that we would be doing in our environment. So, you know, the tasks that you saw about taking down how much items we have, this and that, you know, with the Airlift emergency response, we have a protocol for that. We've got a form, we've got a certain way that people fill it out. So the purpose of that next would be when we develop this into a proper delivery ready experience, that it would be the exact same procedures and protocols that volunteers or pilots would be following in an actual response environment. So this really got us going in exploring.
Chirag, is
Go ahead.
we were able to actually whip this up pretty quickly. So I think Chirag and I talked about the proof of concept, and I think within 3 days we actually had this built and working. So it does speed up the time at which you can create these things as well. So as Chirag mentioned before, if you were to go to a development firm or something like that, it would cost a lot of money and probably months of lead time to do something like this. Pretty quickly.
Exactly. That's a really good point, Benjamin. And actually, I think at the time it was yourself and a high school student that actually got together and created this, just to highlight, I think, some of the points that we'll talk about next. So this really leads to the SilicoLabs software pipeline and how the software works to develop the training and then do some really cool stuff with that training. So at its base, the software that the company's developed allows anybody to create interactive, immersive experiences with our no-code interface and be able to deliver those on any device. So we just saw a desktop version. In a little bit, we'll see a VR version, and be able to capture real-world human and artificial intelligence behavioral data. We'll talk about the data piece in some detail in a second. I'll focus a bit on the experiences. Another thing this proof of concept really highlighted for us is now myself, or with a very limited development team with limited expertise, we can go ahead and develop our own training exercises. So that issue we faced with the long lead times and the huge costs is kind of solved. The other piece is, I would want to change my sequence of events the next year we do an exercise, or the next time we do an exercise. So I can go in and change those sequence of events without having to go back to a developer, because the interface is something that I can interact with. And that really goes back to the core mission of the company, is to make this technology accessible to anybody that's using it for real world kind of utility. So we create those experiences, we export them, and you can use them to train humans in artificial intelligence. We'll talk about the AI in a second. But what really blew my mind was the data piece. So not only are we training humans with these experiences, but collecting, capturing data, and using that data to get some insights. And we'll jump into detail a bit there. So what do I mean by collecting data and using that data? Extended reality technology, we find, is key to understanding how humans behave. And it's such a new technology. It's meant to be delivering an immersive experience. And inherently, by delivering an immersive experience, this technology needs to know everything about the participant that's engaging in that experience, how the participant is engaging with the environment, and how the environment is engaging with the participant. And to do that, these headsets that we have track a whole bunch of data and a whole bunch of things. They track head movement and facial expressions. They've got detailed hand tracking, positional data of various body parts, tracking eyes and where people are looking in that environment. On top of what the headsets are collecting themselves, we have integrations. We can integrate mobile EEGs for brainwave data and specific oxygen levels and heart rate monitoring and breathing rate monitoring, and other integrations to build kind of a more physiological layer of data over to what's being collected from the headset. And this is all on top of the experiential data that's already being collected by the software, how the person is engaging in that environment, where they're going, where they're moving, how much time they're spending in specific places. Whatever experiential data that the trainer wants to identify can and is already being collected just by the inherent virtue of needing to deliver an immersive experience. And that's really what the software leverages to be able to not just use this data to deliver the experience, but extract it and use it to develop insights and other things that we'll talk about more. So let's see this in real life, and I'll hand it over to Benjamin and Kyla there to give us a bit of a demonstration on a task that we've built out for this purpose.
So what you're going to see here is an environment project that's actually led by University of Toronto at State. We're going to use that environment to be able to show you just a couple of the really cool features for our software. And notably, this project is funded by the MSH and AML Innovation Fund.
Awesome. Yeah, I think everyone can see my screen. So some of you on the call might be familiar with, I know a lot of folks in emergency response and especially virtual simulations use the Unity game development engine. And so if this is familiar with to you, this is what the base Unity game development engine looks like when you would start it up. You know, when I started in my PhD, I wanted to leverage these game engine technologies, but I didn't come from a coding background, and it took a really long time to figure out how to use these. If you want to actually utilize a game development engine, you do need to know you have to have a pretty extensive coding knowledge. And you know, I've been building that up over the years, but in doing that, I've also been trying to build accessible tools so that allow anyone to create these types of experiences. So like I said, our software kind of overlays the Unity game development engine with a UI for doing that. So what you do first in our software is we create what we call experiments. And so I'm going to create a new experiment. I'll just call this demo for this purpose. I'll create that. And as you'll see, when I create a new experiment, that we have our experiment dashboard over here. And this is a custom UI that we've created. And experiments are designed by creating and combining what we call experiment elements. And so this is a little overview of all the different elements that you can create. But the basic elements that you create are these modular tasks. And those are kind of, you know, sections of the experience that you want to create. They have a start time, they have an end time, or an end condition. And then when they end, you can actually, you know, link those tasks to other tasks. And as you saw in that AERO example, you know, if someone was to get 2 wrong on that one task, that was a task where we were probing their memory, it would take them to a different task than if they got them all correct. So you can have these really cool branching conditions which take into account how someone actually performs a task, which is really cool. So I'm going to start by creating one of these tasks, and I'm just going to leave it as a default. And then we're going to create a participant profile for Kyla. And so I'll just create a new profile, and I'm just going to call this Kyla, and we'll add that to our task. So now we have a task, and we have our participant profile so that Kyla can participate in that task. And now I can go up and I can actually just run this task, which will start up the Unity game development engine with Kyla's profile, and Kyla will be placed into the ICU. And so I'll try to make this a little bit bigger now. So with our software, we have full hand tracking with the VR headsets. You'll see that this is Kyla's hands. Again, if you're watching this virtually, it might be a little laggy, but the fidelity of the hand tracking is actually quite good. In real life, I can actually see the way that we're tracking all of these and generating these hands is by actually generating each joint in Kyla's fingers. So we can see all of those different joints in her hand. I can turn on the skeleton as well, which is connecting those joints. And this is the type of data that Chirag has mentioned. We're actually able to capture all of this data through the position of those bones. And we can also, you know, see all the labels of those bones as well. The next thing that we can do is in the task is we can add interactive objects for Kyla. So I'm going to add an interactive object. We call these responsive objects. Essentially, they respond to events that occur within the task. So I'm going to create a new one, and I'm actually going to create a mask that Kyla's going to be able to put onto her face. So this the project that we've been working on is for donning and doffing of PPE. So I'm going to create N95, I'll call it, and I'll add that. And so we actually found these N95 masks. It's a 3D model. So what we found is that there's no shortage of 3D models that are available to people online through a variety of different kind of 3D model warehouses. So you can pretty much find any 3D model you need. The real issue is like, how do you take that model and transform it into something in the environment that someone can interact with? And so that's what our software is doing. So what I'm going to do is I'm going to, this is the object editor. So I'm going to actually look up our 3D model of our N95 that we have, and I can select that. And so now we have an N95 mask within our environment. And I can actually bring this up. It's a little small right now. Actually, I can, yeah, so I'll bring this up. I can move it in, I can position this object, in real time as Kyla's in there. I can increase the scale a bit. It's a little small. So I'm going to increase that scale. The other thing I can do is I can actually have Kyla in VR actually place the object where we might want it to actually start in the experience. So Kyla, if you want to, we typically can just put a mask on top of one of these masks so that someone can interact with that mask. And next, what we can do is we can actually create other types of interactions with that mask. So perhaps we want to, display some information about different objects in the environment when somebody looks at them or points at them. So what I'm going to do next is I'm going to go back to Kyla's participant profile. Actually, sorry, I'm going to go back to the mask first. And what I'm going to do is I'm going to add what we call a signal zone to this mask. And so here I'm adding a signal zone to the mask. And I can, just like I was moving around that mask, it's quite big. We don't want it that big. So I'm just going to make that this signal zone so that it's tightly around the mask. And so you'll see that Kyla now, you can grab that mask too. And so we can see that that signal zone is on that mask. We can make this any color, any type of color that we want as well. So we could also make it invisible, which is probably what we would want to do here. But I am going to, I'm going to just maybe make it a little less visible. But I still want you to see how this interaction is happening. So once we've created a signal around the object, we're going to actually create a signal tag for that. So I'm going to call this N95. And so this signal is now emitting this N95 signal, which can then be detected. And so the next thing we're going to go ahead and do is we're going to add a detector to Kyla's fingers so that when she points at this object, we can have something happen within the environment, essentially. So I'm going to go to the detector tab of our participant profile, and I'm going to add a ray detector onto Kyla's left hand. And so Kyla, you'll hold that up, and you can actually, I'm going to put the bones back on just so you can see. So right now, this detector is actually attached to Kyla's wrist, which is not ideal. I'm going to attach it to the tip of her index finger. And obviously, that's not the right direction. But we can modify, just like we were moving around the position of that N95 mask, we can also modify the position of this ray detector. So I can change the rotation here so that it's actually just pointing out from her finger. And then we can say what signals we want this ray detector to detect. So I'm going to change that to the N95 mask here. And now that we have a ray detector that's going to pick up that signal, we can go to the events tab of our ray detector. And so that's this little button here. And you can see that it has all of the different events that can occur to this ray detector. So one of the things you really want when you're doing research or you're doing any sort of training is you want to know, you want to have access to anything that can happen in the environment. You want to be able to record that data, and not only so that you can know what people are doing, but also so that you can actually tie that other types of data to that. So for instance, if we're capturing brainwave data, we have a brainwave device on Kyla's head. We can get all that raw data, but it's pretty useless unless we actually know what Kyla's doing at the point of that brainwave data. So by having access to every single event within the environment, we can actually link otherwise kind of useless data streams, raw data streams, to actual events, which allows us to do really cool analyses. And so I'm going to go to the on-detected event here. And what you can do is you can add responses to when this event happens. So what I'm going to do first, and it's unfortunate because I don't think you're going to be able to hear this, but I'm going to add an audio response just to let Kyla know that she has pointed at this. So you can't hear it. I can hear it because I'm right behind her. But now every time she points at this mask, there's a coin sound that's actually happening. So this on-detected event occurs right when Kyla points at it, and then it won't occur again unless she removes her pointer and points at it again. There's other types of events that can happen here too. A well-detected event, which would be that event would fire over and over again while she's pointing at it. And the undetected event tells us when she stops pointing at that. And so it's cool that we have we're able to play a sound for Kyla, but we might want to have something else happen within the environment when that event occurs. So one of the ways that we can kind of link events across objects is by creating variables which track those events. So I'm going to go to the variable tab in our experiment dashboard, and I'm going to create a variable to track that. And anyone that's done any sort of coding, you'll see that we have all the standard kind of variable types that you would have when you're coding something. So Boolean values, which are true and false, integer values are whole numbers, float variables, which store decimal numbers. We can store string values, we can store coordinates, a wide range of different variable types that we could use. For this one, it makes sense to use a Boolean, a true or false. So we can say it's going to be true when she points at it and false when she points away from it. So I'm just going to create that. I will start this as false, and then I'll say I'll call the variable pointing N95, and we'll create that. And just like we added that audio response for Kyla when she pointed at it, I can add a variable response to that event. So here I'm going to actually reference our new pointing 95, and I can say I want that to get set equal to true when that event happens. And then we want it to be set back to false when Kyla is not pointing at it anymore. So on undetected, we're gonna have another variable response, and we're gonna change that pointing detected variable, that Boolean variable, we'll change it back to false. And so now what you'll see is that we've created this variable. You can actually see it over here in our experiment demo. And if you point at it now, Kyla, you'll see that this is actually changing from true to false. So Kyla points at it, it's true. When she points away, it's false. And so that's really cool. We can track that. It doesn't give us much more information about the event other than just what it would get output from that event anyways. But what it allows us to do is it allows us to do other really cool things. So perhaps we want to tell Kyla about that object when she points at it. So what I can do to display kind of information to the participant within the environment, what we can do is we can create a screen that can display some information. So I can come into this screen tab of Kyla's profile, and I'm going to add a screen to Kyla's left hand. And I'm going to create a new one, and I'm going to say N95 info. And I can add that to her hand. And now it's covering the whole screen. And that's because you can set up screens so that it overlays on top of the entire participant's viewpoint. So if you wanted to have some sort of heads up display, you could use screens like that. But we want to change this to a screen location or a scene location. And so now what I'm going to go back and do, and actually I'm going to make this a little bit smaller as well. So I'm going to change this to the width. I'm going to put at 1, and I'm going to put the height at 0.5. Oh, I think I might have to put that 1. So let's just put that 2 and 1. So we have that, and I can come back to Kyla's hand where we place that screen. Sorry, I think some of the icons for some reason are not working right now. So this is quite large. We don't want it this big. But first, before I change the size, I want to actually put that information about the N95 mask on there. So I'm going to say, I'm just going to put this is an N95 mask. And so I don't think you might not be able to catch it right now. Maybe on Kyla's screen. Okay, so she can actually see this. So it's actually just showing up that text as I'm writing it. And I'm actually just going to increase the font size a little bit so that it takes up more of this screen. I'll make it a bit bigger, and now it's centered. And obviously this is not at the right position. So what we'll do now is we can actually come back to Kyla's hand, and instead of changing the position of it. Oh, and I think what we want to do is not put it on your wrist. We'll put it on your index tip as well. So, okay, just hold that tip steady, Kyla, and can you make it so that you're kind of like pointing at it, just so I have a good sense of where this should be. But I can actually now modify the rotation of this so that it's actually more visible to Kyla, and obviously it's still much too big. So I'm going to then decrease the scale of that as well and make it quite a bit smaller. And I'll come back to the game view so I can actually see what that looks like on Kyla's. And I can also come in here and I can make these kind of, instead of using that, I can see what Kyla's seeing, and I can use that to actually change the position of the screen as well. So I'm gonna move it over just a little bit so that's just the side of her hand. Maybe I'll bring it back a little, maybe down a little bit and back a little bit too. And so now we have this screen, so Kyla can see that on her hand when that pops up. But obviously we don't want to display this the entire time that that's up. We just want that to get displayed when she points, at the N95 mask. So I'm actually going to turn the visibility of that screen off right now. And I can come into the conditions tab on this screen object. And now we can actually reference our Boolean variable that we know will be true when Kyla points at it and false when she points away from it. So I'm going to use that to create a condition on the screen. And so I'm going to create a variable condition where I am referencing our 95, our Boolean variable. And I want to say when that's true, then we can have, just like with the other object where we have those events, now we have events on this variable condition. So we can say when this condition is met, we can have things happen, or well, the condition's met, just like the on condition met is just like when Kyla first points at that. This is when it first changes, when that condition is met. And then the well condition would be like Kyla pointing at it as well, the variable is meeting this condition. And then the on condition unmet would be when that condition is unmet. It's when it changes back to false. And so what I can do is I can add a response on our condition met. So I can say, when this condition is met, we want to turn this screen on and we want to make it visible. And then when this condition is unmet, what we want to do is we want to set the state of the screen as off and not visible. And so now, Kyla, can you point at it? Okay? We might have to restart. We've been having some of the real-time condition stuff is still a little finicky. So let me make sure I have it right. I do. So try it again. Okay, so I'm just going to restart this. So as you can see, we spent a lot of time getting everything running in real time. There are certain aspects that we're still just tweaking to happen in real time. So sometimes you have to restart it for those things to happen. So, oh, there we go. And so you'll see that as Kyla points at that mask, that you're gonna maybe move it back to where it would be. And when she points at that she's actually seeing that information about it. When she points away, that information disappears. We can also really do cool things with eye tracking as well. So if we wanted to have a detector on Kyla's eyes, for instance, we can actually do that as well. So I'm going to just do that really quickly to just demonstrate that functionality. But I'll add a detector to Kyla's eye. I'll make this and change the colors of these rays as well. So I'm going to make this one red so you can see. But you'll notice that Kyla is not moving her head, but every time she moves her eyes, that's when that ray detector is actually moving around. So we can actually add those ray detectors to any sort of object. So you can actually have it so that when she looks at the mask, that information pops up, for instance. I'm going to delete that though. The next thing, really quickly, we gotta pass it back. Oh, I'm so sorry. I didn't realize the time. Okay, that's okay. The one last thing I was going to show, maybe I can, if anyone wants to come up afterwards, you can actually socket things onto your face and whatnot. I apologize, I got carried away with the time. So I'll pass it back to you, Chirag. Thank you.
Awesome, no problem. Thanks so much. So what we saw there, all the conditions and everything that Benjamin was talking about is what we mean when we say, we can set different conditions to actually collect and store that data. And then what you can determine, or what the trainer can determine as data that's important to be collected. And that really fits in with our final conversation about patterns and predictions. This data is being collected, and we can use this data to identify patterns. Emergency preparedness is all about, patterns of what usually happens and how we can use those patterns to make predictions so we can prevent that from happening in the future or promote that from happening. We always talk about identifying patterns. For us specifically, for AERO, it was how can we see pilots reacting in stressful conditions, and how do they usually respond to various stressful conditions, and what protocols can we build to support them in those stressful conditions. And that needs an understanding of how they typically react. So we'll talk a bit about how we're doing that, but creating those data variables that we can collect as trainers to identify those patterns is key. So many different things can happen, and I can change my protocol very slightly for it to have a very different effect. So now with what Benjamin showed you, we can create different types of protocols and test them against each other, and do a better understanding of cause and effect relationships between those changes that we make to our protocols and procedures and how they actually impact performance of our volunteers and staff in those sort of stressful real world environments. So that's all really key to making quality predictive analytics and comparing across experiences, and then using that knowledge to do a bit of knowledge translation and training public and training our volunteers to better be able to respond to our protocols that we've identified. Really quickly, I'll touch on a couple things that are coming up in the very near future that are going to enhance this experience or this technology even further. The first one that we're working on is an immersive creator interface. We're in our development pipeline is actually bringing everything that you saw on Benjamin's desktop into a creative, into an immersive experience itself. So actually being able to put on the VR or the AR headset and dragging and dropping assets and creating different conditions all within that immersive creative experience. And that itself destroys a few barriers where, it's very intuitive to drag and drop things, may still require some technical ability to use a computer software. We've got a partnership going with a company called Gamma. Gamma develops data analysis, and so they visualize this data for us. This data dashboard that you see in the middle here is from an automotive training task, and it shows an individual compared to a group and their results basically from that task. So again, using our data to identify these key data points that we want to use, and then visualizing it in a way that's useful to a trainer or your organization is again something we're working on now. The last thing I'll talk about is generative AI. Everyone's heard of ChatGPT. Generative AI is something that creates information and creates art, creates language, whatever it might be doing. There's actually a huge push within Ontario to develop generative AI that works within 3D immersive environments and actually changes the environments in response to user feedback. So if I'm a police officer and I'm patrolling a digital twin of my city, the decisions I make will end up determining how that environment then ends up reacting or engaging with me, which creates for a more interactive, a more organic training experience for people. And all this stuff is in the near future that'll start to enhance some of this technology. And with that, I'll conclude our talk and hand it back to Dr. Asghari for any questions.
Right. Thank you very much. Thank you. Very, very, very interesting. And for those of you who are already involved in building VR applications, especially using Unity, you know how difficult, complicated, especially the learning curve is. This tool or platform is basically making it faster, quicker, easier to learn and use this. And especially if you are targeting any sort of training activity, this is the tool. Is it the Unity platform that you can faster training VR-based experience? With that, I first of all again thank you for your presentation and thank you all for participating. We have a question online, but I'm going to ask this. But if there are questions from the audience here, please ask. This came along with it, so I'm gonna go to that first. One of our participants is asking if basically I read the question because I won't be recording this. I want to make sure that this is also recorded. Says, hi, as a math educator, I wonder if these can be used for some math subjects that are heavily skill-based, usually for first and second year undergrad.
Yeah, so using the tool as an educational tool. Yeah, yeah, for math. Yeah, for coding. And so yeah, as you saw, I think walking through that UI. So the UI for building those variables is actually something that we implemented in response to some of our user base. It was, we had it before where you would just click a float or an integer. And so what we've done with that new UI is we've actually created a space there so that when you click on those variables, that you'll actually be able to learn what each one of those variables are. We actually use the same language that you would use in the coding. So what we want to do is we want to abstract it away enough so that you don't need to learn C# coding to do these types of tasks, but we want to still educate the user as they're going through that so that if they do want to, eventually go in and start doing their own custom code scripts. I should mention you can have custom code scripts integrated into the framework by referencing those objects or putting objects with scripts into the environment. That they already have a really good understanding of how those mechanics work on the back end. A lot of the signal and detection stuff that I showed, the interaction stuff that you see, that's all very closely related to how you would actually code that on the back end. So it's a level of abstraction up, but we've tried to keep it very close to the coding so that as you develop those experiences, you are actually learning, how you would code those if you were to go in and do that as well. So I think it can be used on its own to teach folks about math and 3D environment and especially vector math and linear algebra and stuff like that. I think it's a really cool learning tool, but also for coding as well. Yeah.
And just to add on to, you collect a lot of behavioral data really quickly. So for learning how to do data analysis, it gives you that data set that you can actually start learning yourself. So
Yeah, that's a great, yeah. All of the data that comes out is completely standardized on every experiment that you create. So anytime one of those variables gets updated, that gets output as with a timestamp and all the information, the event that occurred and all of that stuff. So once you create these analysis pipelines, or if you wanted to create one as a class, then that can be applied to any data set that comes out of the software.
Any question here? Yes.
Yeah, so thank you very much, Benjamin. I'm not sure whether they can hear me with Zoom, but my question is a follow-up question about the AI techniques. How the experimenter, the platform will cover the AI and the machine learning particularly.
Yeah.
Interact with and then get the.
Yeah, that's a great question. So yeah, this is a new version where we actually introduced a lot of the VR methods with the hand tracking and the eye tracking and head tracking. And before we actually had a more basic system for doing more like desktop and moving around. But what we did in the old system, which we'll be integrating into this system, is the ability to actually pass out data from the environment to a deep learning agent. And that agent can actually process that data and send back an action. And you can define the actions that agent can take, and they can be analogous to the actions that a human could take. So for instance, you could define an action space of the bones in the hand, and that agent could actually move those bones according to that action space. It could get that information from the environment and choose where to move its hands, how to move the bones in the hands. You could have an agent actually do that. And the type of data that I'm talking about, so for instance, we have folks at Milo, which is a big AI institute in Montreal, that we're actually passing out the pixel data on every screen to a deep reinforcement learning agent. That pixel data, which is just a matrix of RGB values, is actually processed by that deep reinforcement learning agent algorithm. And that algorithm then passes back to the environment an action to take. So you can think about how you're playing a video game, you have up, down, left, right arrows to press to go move through that environment. You look at the screen, and based on what's on the screen, you decide in your brain what button to press. It's the exact same methodology for the AI, where you're passing out that pixel data. It goes, this is on the screen, this is the action I'm going to take. And then it can learn to actually behave in these real world environments the same way that we behave in those real world environments. So you'll be able to define those custom action spaces and custom observation spaces to pass out to the agent. Does that answer the question? Yeah.
Thank you very much.
No problem.
Any questions? Yes, Francis.
Thank you for the presentation. My question is, do you think users need so many skills and support use the application?
Yeah, no, that's a good question. And we've actually found it's been actually really exciting for us to watch new users because they have been able to pick it up really, really quickly. So just a couple anecdotes. We had a high school student, an intern last summer that we just gave him the software and a couple of videos, and he actually didn't have any coding experience, didn't work with VR or anything, and had created a VR experiment in, I think, 2 days. We also licensed to a lab at Toronto Rehab, and they had an undergraduate who also had no coding experience, no 3D environment experience, and they created a fully 3D immersive experimental task within 2 days as well. So it's really quite quick to pick up. So I know I was clicking around and I'm very fluid with it, but yeah, we found with users it doesn't take the onboarding time doesn't take very long. Yeah, no problem. Yeah.
So thanks for your presentation. I was wondering how feasible would it be to like maybe work with like if I was working on a group and wanted to work on one experience to work like simultaneously on the experience like with maybe one person in another country or somewhere else and we're not all in the same environment. How feasible is something like that?
Yeah, so right now, not that feasible with the way the software is right now. What we have been doing though is that's a big one of the things in the future that we really want to develop. We want to develop not only like being able to create together in those spaces, but also being able to have multiplayer experiences. So when you're doing training simulations, that you can actually have multiple people in those situations. So you'll see that I set up a player profile for Kyla, and I put that into the task. That we've actually set it up so that we can put multiple player profiles into the same task. And so what that allows you to do is it's set up nicely for that multiplayer experience, but you can also have those player experiences be different, right? A different person might be able to access or interact with different objects within the environment. They might get different types of information than another participant. So now you can tailor that to the type of task or the type of role that person is in. Like Chirag mentioned, we really want to take that whole UI, and the reason why we've been making it so that we can create all of that stuff in real time, like we were showing today, is that we can actually take that UI and put that into the environment and have something on your wrist pop up and say, I want to choose that N95 mask, and I can put that in, and I can click on it to put a signal on it. I can click on my finger to put a detector. So doing all of that in the immersive environment is something that we want to do. So having that multiplayer experience with that creation tool, that I think is what you're getting at. So that is like a very high priority for us. Although we have a very limited development team. I'm the only developer on the team. So yeah, it's been an experience, but yeah, hopefully we'll get more support soon.
Stay in touch though, like
Yeah.
grab a card and see candy on your way out.
Yeah, we have cards and candy up here for anyone that's here.
Okay, I don't see any other question on the participants, online participants, and also seeing.
I have a question. It's a very general question. I'm sorry, because I likely don't have that much experience of studying transportation. But I'm very much interested to work on this VR environment. So basically how, kind of convenient or how is it possible to integrate this using Unity in simultaneously, getting the data and outputting the data into other software. I don't know if I'm
Yeah, could you give me like maybe an example? Yeah.
If you want to integrate, what you want to build in the environment,
Yeah.
you get something because it's just not going to be a very simple one. And you want to have something like a little bit more complicated in a sense
Like
that
a city or something, or
Exactly. And you have something, beforehand that, like you have it in the Mapbox or something like that.
Yeah.
Is it possible to sort of this be integrated with the Unity so that it gives you some sort of, you don't want to start from the scratch?
Yeah, absolutely. So Unity is one of the reasons we chose Unity to develop with is because of its really nice integrations with a lot of software. So the 3D models especially, typically any 3D model type can be converted into any other 3D model type. And with Unity, it supports a wide range of 3D model types. So it can support, you can import object files, you can import FBX files. So any of those 3D models that you have are easily converted if they're not already compatible with Unity, they can be converted into that. And you could drag that city and put it right into the environment and then start creating an experience with our software like within that. For automotive, I think it'd be an interesting case because I think you want, you're driving, I'm assuming. And so tools like that, there might be ways of doing it within the software. There are ways of like creating movements of objects and stuff and doing movement sequences with objects that I wasn't able to get to today. But so you could do something like that where you have somebody in a truck or in some sort of transport device. But we're always interested in working with these new use cases because, really what we're trying to do is find like the fundamental kind of mechanics that would allow for the widest range of use cases. So it might be the case that creating a driver simulation, we can create more of those fundamental tools for doing that. So we're always interested in working with folks, and if we have capacity developing those new features, that's how a lot of the features have been developed in the software. For instance, I didn't get to show you the socketing, but you can putting things on and socketing into other objects, so putting a mask on and putting a face shield on. That was not a feature that we had before Ali reached out to us with the UHN project, and we implemented that so that we could actually accommodate that type of interaction within the environment. And I think that's a fundamental type of interaction, whether you want to connect something to your face or connect two objects together. That opens up a huge wide range of other types of tasks that you can do. So not only putting a mask on, maybe you want to teach someone how to put a drill together, a tool together. Now you can actually put sockets on the objects and you can socket them together. You can tell someone, oh, that was the right way that you did that, or that's the wrong way, all of that kind of stuff. So that led to a whole bunch of new.
Just one last thing.
Yeah.
Isn't it a bit overwhelming at this point? Is it like, is it because you have done it? I think it's so much effort for you to accomplish this, and it's just quite impressive. But it's like I don't want to pick it up if I can't accomplish it.
Of course,
alone,
yeah.
Because
Yeah.
these sort of things it's so it's still so fancy, so advanced that I feel like if you want to do it, you really want to get the sense that it's going to be something, get something out of it,
Absolutely, yeah. And you're right. Like I think it does seem overwhelming at first. So what we've really tried to do on the UI side, I don't know if you noticed when we were placing the objects into the environment, or we were placing a screen, or like whether it was the event on the detection or the event on the object, all of that UI is standard across anything that you add. So while it might seem like really overwhelming at first, you actually once you start using it, you see that all the UI is very consistent across. So once you kind of learn it in one place, you learn it somewhere else. So we're trying to make that UI as intuitive as possible, so that it does seem like there's a lot of features, but all the features have very similar ways of setting them up, like very standardized ways of doing that, which I think accelerates the learning. One of the things we also are going to be working on is just video tutorials and stuff like that. So breaking down like a single kind of mechanism. How do I create a socket? Here's like a 2-minute video where you can just watch that and you can just learn about that mechanics. So having that built out, I think is really going to accelerate the user experience as well. But we're very committed to making it as seamless as possible. We want people to pick it up and within an hour have something that they're interacting with and doing some cool stuff with. So templates too.
We also have a Slack community as well.
Yeah. We're creating templates for things as well. So you want to create an object with a socket, here's one created. You can see how all of that works. And then you just modify that. You change the object that the object has a socket, or what have you, or change the responses on that. So we'd already have that set up, and you can learn through kind of emulation.
Thank you very much. We are a bit over our official time. I see another question though. Chirag is typing the answer to that question, but I'm going to ask, but because really people who are online and we're online says so far, their time is their short of time. They can, of course, it's their time. But we, as I said, we record this session. We will publish them soon. But if okay, question answered, then I'm not able to read it. Read it just for you so that the question was basically how would you protect the users that the data is collected from? Would there be an agreement to protect their privacy, etc.? I'm sure this is something that we all have to deal with it, but please, if you have answered.
Yeah, absolutely. That's a great question. I mean, that's like something that we are thinking a lot about. So right now with the software, you can export those experiences to local devices, and that data is stored on those local devices in CSV files. So from a research perspective, you would just do your own data security processes. With something like delivering it online, we have an API, a secure API, which actually uploads that data to whoever's created that experience. So it's kind of like when you send a survey out to somebody, you'll get those responses. You'll be able to log into your account on the survey software, download those responses. Very similar interface that we've developed. I know that there's certain institutions. We started working with Toronto Rehab, which is part of the hospital network there. So they have data security stuff. But we're also looking at ways of connecting these data output and data collection pipelines to secured servers as well. So we're always happy to work with institutions to make sure that we meet those data collection needs. We have gone through several research ethic board applications now with the software that, so we do have a good understanding of what is required for most use cases, although I know that certain institutions have more limitations to how that data can be collected and stored too, but we're always happy to work with those institutions.
Thank you very much. And yes, the data for these applications, they are stored locally, not online. So I know for you in that sense. But thank you again, Kyla, Ben, and Chirag online. And I also would like to thank Dr. Ahmed Mohammadi, who was organizing basically this series, and he will be moderating next session. And also would like to thank Francesco for helping us putting everything logistically together. And with that, we are going to conclude. And our next session will be on Friday, April 28th at 12 p.m. Please join us again. And it is another very interesting topic from our colleagues. Thank you so much. And we conclude this session.